as night wraps a calm blanket around the world outside. The light inside is subdued, easy on your eyes, with delicate hints of blue from distant monitors and a muted amber glow from the safety lamps along the corridor. The air is cool and still. Your footsteps move quietly over the floor, and each step fades almost as soon as it sounds, as if the building is a soft space designed to absorb hurry and turn it into quiet. You find your seat in a small control room that feels like a cocoon. The chairs are plush and slightly worn from many nights of patient watchfulness. There is the faint scent of clean electronics, a soft mix of metal and dust kept at bay by steady, careful maintenance. A single fan hums with a rhythm that is regular and gentle. You can feel your own breathing settle into that rhythm, slow and even, as you rest your hands lightly on the desk and take in the gentle landscape of blinking indicators and rolling plots. This is a place where almost nothing happens on human timescales, and yet everything is happening all the time. Invisible particles pass through you, through the building, and through the earth, like quiet travelers from distant places. They hardly ever touch anything. They are called neutrinos, and they carry stories of the sun, of the atmosphere, of faraway cataclysms, and of the early moments of the universe itself. Most of them do not speak to us, not even in a whisper, but sometimes, very rarely, one leaves a trace. This is why the observatory exists. It is a quiet listener, waiting for a rare word in a language of light. You glance at the night log. The pages are neat, full of calm handwriting. Evening calibrations completed. Dark rate nominal. Photomultiplier voltage stable. Trigger rate steady. Outside, the night is patient. Deep underground or deep under polar ice, the detector itself rests in near-perfect darkness. There is a feeling of being embraced by the earth, or by ancient ice, held safely away from the busy signals of the surface, away from the glitches of street lights and the sudden starts of everyday life. The detector waits in that quiet, and you wait with it, like a lighthouse keeper in reverse, watching for glimmers from within rather than flashes from without. Imagine walking down a long tunnel, the air growing cooler, the world growing quieter with each step. You reach a vast cavern carved into rock older than memory. In the center is a pool like a midnight lake, pure water so clean you cannot smell it. Around you, large glass eyes are arranged in rings, fixed to the walls, the ceiling, and platforms that reach under the water's surface. They look like enormous seashells, deep and glossy, each holding a delicate photomultiplier tube that can taste a faint blue glow when a particle races through the water faster than light travels within that water. It is a kind of optical whisper called Cherenkov radiation, a cone of pale light that opens briefly, touches the glass eyes, and is gone. The water is completely still. It reflects the quiet lights like a soft silk. The gentle rhythm continues as your breath rises and falls. sensors hang like beads in transparent ice. Each sensor has a heart that can feel a tiny wave of light as something passes by, and those tiny waves, recorded across kilometers, form patterns that tell a story. The winter overcrew lives nearby in a cluster of buildings that hum like a sleeping animal, warm inside with the subtle scent of wool and recycled air. When the wind is gentle, it becomes simple white noise, like a soft ocean far away. When you step outside, the world is so quiet that you notice your own footprints in the snow, as if they are gentle punctuation marks on a fresh page. In both places, whether under mountain or under ice, the patterns of light are the language, and the night watch is the patient reader. You settle into your seat and watch the screen where that faint language is rendered into lines and dots and shaded graphics. You feel a small sense of ceremony as you check the list. The high voltage values are smooth, like a fence with no gaps, the trigger counts gliding along within expected ranges, the calibration LEDs in the detector pulsing with regular, measured beats to keep the timing aligned. There is something soothing about the regularity of it, like the distant clicking of a metronome in a quiet studio. Each check is a gentle touch, a way of saying we are here, we are listening, and everything is working as it should. Neutrinos are shy travelers. Imagine a rain of particles passing through your body in this moment, countless streams that ignore you, like polite strangers in a wide silent hall. Most of them come from the sun, produced in the deep, calm fusion that brightens the day and warms the earth. Others are born when cosmic rays meet the atmosphere, creating showers that whisper their own messages through the planet. Some come from reactors, quiet signatures of human-made heat. Others, rarer and more ancient, have traveled across space for millions or billions of years. Each one carries a tiny bit of information, a flavor and a direction and an energy that are like a set of gentle notes in a long music. You do not need to reach for the details right now. You can let the idea wash over you like a soft tide. The gentle rhythm continues. Sometimes at night you feel the presence of history in this room. There is a careful stillness to it, a memory of people who spent years imagining how to hear something that does not want to be heard. A long time ago, a physicist proposed the existence of these particles as a way to explain missing energy in a subtle process. It was a careful idea, a way of balancing a ledger between what goes in and what comes out. Later, experiments near nuclear reactors confirmed that these quiet particles are real. Deep in a mine, huge tanks of cleaning fluid or heavy water became ears for the universe, and in those ears came the sounds of the sun and the atmosphere. The story unfolded slowly, like a long walk where the scenery changes gradually and comfortably, each step revealing another view, another calm insight. At your station, a small status panel shows the heartbeat of the system. In one corner, the background light level, or dark rate, is displayed as a gentle rolling line. Photomultiplier tubes are sensitive, so sensitive that they can mistake the tiny thermal flickers of their own components for light. Those flickers, the random little backgrounds, are like the soft whispers of your own mind, you settle into bed. They are normal. The system knows how to ignore them, to let them fade into the quiet. The triggers are like attention, waking only when enough pieces align to suggest that something real and interesting happened. The software listens for coincidence, for a group of sensors that respond almost at the same time, arranged in a way that resembles a passing wavefront. The gentle rhythm continues, and you let your shoulders relax, your hands resting light and still as the night leans softly forward. Imagine a pulse. It begins quietly, a small set of sensors lighting in a cluster, then another cluster a few meters away, and another, a pattern unfolding with the unhurried certainty of ripples in a pond. The reconstruction software reads those times and positions and makes a picture. If the pattern is a straight, elongated set of hits, it may be a track, the signature of a muon neutrino, creating a charged particle that travels like a chalk line across a blackboard. If the pattern is more spherical and compact, like a soft glow expanding and fading, it may be a cascade created by an electron neutrino or a neutral current interaction where the details blend into a pooled light. Each shape is a phrase in the language. Each event is a brief, polite introduction from a traveler who will be gone almost instantly. There is a deep comfort in knowing that the observatory does not need to capture every single neutrino. It only needs to catch a few, a representative handful, to tell us about populations and energies and directions. The detectors are vast because the interactions are rare, and this makes the night feel even more tranquil. So much space is almost always empty of events. It is clean, empty space, a still surface upon which you can rest your gaze. The occasional blinks are like distant fireflies in a field, each one a tiny, grateful gift. In the cavern or under the ice, the hardware quietly does its work. A photomultiplier tube sits inside a glass sphere. The glass is smooth, and if you were to run your fingers over it, it would feel cool and perfect, a surface made to spend decades underwater or encased in ice. Inside, the photocathode is like a thin velvet that turns light into electrons, and those electrons cascade through a structure that amplifies the signal. The tube is fed by high voltage, but the current is small, the kind of delicate breath that makes the electronics sensitive without strain. Cables carry the signals to digitizers, time stampers that know the moment of each pulse with precision that would be surprising if it were not handled here with routine care. The software accepts the shapes, compares them with templates, and tucks them into memory. You do not have to hold the details. You can just imagine the slow, careful process as a soft assembly line, boxes moving past gently, each one labeled and filed. The lights on the console are not harsh. They blink slowly, like the breathing of a sleeping pet. The screens do not shout. They present information as if they could wait forever for you to read them, because in the world of neutrino observatories, everything is patient. If something changes in an unexpected way, it will do so gradually and without alarm. You sense that now, and your body recognizes the safety of this place. The chair supports you. The soft fabric is pleasant is dry, not too dry, and it carries a hint of the rock or the ice, a clean and ancient smell. The gentle rhythm continues. You think of the sun and its core. Fusion happens steadily, a quiet fire that is really more of a constant glow. Every second, the sun sends out untold numbers of neutrinos, and they pass through space in straight lines, unaffected by magnetic fields, passing through clouds and stone with hardly a ripple. When the Earth rotates, you might imagine the night side of the planet facing the sun in a different way, and still the neutrinos sail through, even through the Earth itself, with the slightest of chances to pause and leave a trace in detectors. The idea that a particle travels through an entire planet almost without noticing is not meant to be exciting here. It is meant to be calming. It is a reminder that the universe has layers of gentle subtlety hidden within things, like a quiet echo in a large room that you can only hear when everything else is silent. This watch is not lonely. The observatory keeps company through the data streams and the clockwork cadence of checks. Perhaps your colleague from the earlier shift left a note with a small drawing in the margin, a tiny doodle of a photomultiplier tube with a smile. The night has a community of listeners in other places too, other facilities where people are performing their own careful rituals of attention. An observatory in Japan, tucked into the mountain, where a large water tank breathes with occasional pale rings of light. An observatory in Canada, where heavy water once revealed a beautiful truth about neutrino flavors. An observatory in Italy, where liquid scintillator, clear as glass, glowed with the faintest signals. And far away in the south, the array under ice. You are connected to all of them through a simple fact. You are listening in good company. The science of neutrino flavors can sound complicated when you are fully awake, but tonight we treat it like a soft pattern, like waves gently passing through one another. Neutrinos come in 3 flavors, and those flavors are like names given to particular ways they can touch matter. But in flight, they are mixtures, and the mixtures change with distance and energy, like colors shifting under a moving light. This phenomenon, called oscillation, is the universe's way of whispering that particles are not always what they seem at first glance. In deep water or deep ice, we notice those shifts as quiet changes in rates and shapes. Over long distances, the mute travelers slowly trade identities. We measure those trades with care, as if measuring the length of a lullaby's notes, and from that we learn delicate aspects of their masses and their relationships. There is no need to hold the mathematics in your mind now. Just let the idea be like a mobile hanging over a cradle, gently turning. There is an old phrase in this field, ghost particles. It sounds dramatic in regular life, but here it is almost literal and yet utterly gentle. They drift like phantoms, but they are friendly, and their passing is a comfort, not a fright. You imagine a single neutrino, born in the core of a star, gliding outward effortlessly, through layers of plasma and magnetic fields that hold back other things, but not this visitor. It arrives near a detector after a journey beyond countable steps. It does not intend to be noticed, and yet, in a rare, soft chance, it taps into a molecule, transfers a small portion of its energy, and in that instant, a cone of blue light blooms into existence, just as quickly fading. The detector is like a librarian who hears the faintest brush of a fingertip on a page, and in hearing it, records that a book was touched at a certain time, in a certain way. The story accumulates one page at a time, gradually, welcome, but not urgent. The gentle rhythm continues. You watch the DAQ, the data acquisition summary, calm and steady. Trigger rate holds within its nightly band. A rolling buffer shows clusters of pulses that are too small to be meaningful, the software letting them pass like leaves in a stream, while it saves the ones that match curated patterns. On a side screen, a monitor loops through views of the cavern or the facility hallway. A red light glows above a door that will not open while the detector is active, a small reminder that this is a place for quiet. Your cup of warm tea or water sits within reach. You lift it with unhurried care, feel warmth on your fingers, and take a slow sip, savoring the simple comfort of temperature and the way it spreads gently into your chest. Calibrations are a serene routine. Every so often, the system sends controlled light pulses into the water or the ice, tiny flashes from LEDs designed to mimic the timing of real events. The detector responds, and from the response, the software learns whether the timing remains true and the gains remain stable. Here the idea of stability is as soothing as a steady rain outside the window. Everything staying in place, everything in its right position. Outliers happen, but most points are nestling close to the line, like sheep in a field, drawing near to one another for warmth. Think now of noise, this word that often carries a negative slant. In the observatory, noise is not a nuisance. It is a background whisper that makes the occasional word stand out more clearly. Thermal noise in a photomultiplier tube. Radioactivity in the rock. Very low and mostly harmless. Just a reminder that nothing is ever fully still. The analysis code learns that whisper and tucks it away, giving it a small corner, allowing it to be present without letting it disrupt the conversation. Peace often includes soft background sounds. The night is rarely silent in a strict sense. There is the fan. There is the slight buzz of a display. There is your own breath. They build a nest around you, a structure that supports rest. Like a caretaker tidying a room, the detector's software performs housekeeping. A process checks for sensors that might be slightly off in timing and nudges them back into place. Another process compares local rates to long-term averages and marks those that drift. A separate thread checks the temperature and humidity in the cavern or in the electronics rooms, verifying that the environment remains gentle and friendly for the instruments. Alarms are set to whisper, to call for attention only if really needed. Most of the time, everything is quiet. The logs fill with short, calm entries. Seen at 0045 HV stable. Calibration pronounced good. No errors. This night, obsidian mirror. If it is a liquid scintillator or solid material detector behind shielding, you might see panels and carefully arranged vessels, all tucked in behind layers of protection. Under ice, you would not see the array directly. Instead, you would imagine it under your feet, and perhaps you would step outside to take in the sky. Under the mountain, the rock above is like a soft and heavy duvet. Under the ice, the air is crisply clear. Stars feel close, the band of our galaxy an undisturbed, powdery line. Your body recognizes the scale and relaxes. You do not have to hold the universe. It holds you. The gentle rhythm continues. There is a network that connects neutrino observatories and other watchful instruments. When a rare burst from a distant stellar collapse sends a wave of neutrinos, the detectors will notice a gentle upturn in the rate. If that happens, a quiet alert traverses the globe, a soft signal that something important to astronomers has occurred. It is an early whisper that light will later confirm. Even this possibility is not meant to bring urgency tonight. It is comforting to know that the listening is shared, that no one person carries the responsibility alone. Systems keep watch, people rest, and both function best when calm. The night watch is both a practice and a posture. You breathe and keep the posture. In between system checks, your mind drifts, not in a hurried way, but like a slow floating leaf that is guided by small currents. You think gently about the nature of a neutrino. It barely touches anything, because it interacts through the weak force, a force that lives at distances smaller than a single atom. It has a little mass, not quite zero, which tells a story that physicists learned through the careful measurements of flavor changes over distance. It moves with near light speed at energies common in these detectors. Some neutrinos are low energy, such as those from the sun, and some are extremely high energy, like messengers from events far beyond our galaxy. The observatory has sensitivity to certain ranges, and across the world, different detectors complement each other like instruments in an orchestra, each playing its part in the score. The sense of scale is easy to hold here. Everything about neutrinos is small and rare, and yet everything about the detectors is large and quiet. It is like listening for a single drop of water in a pool the size of a cathedral. To make it easier, you remove the loud noises of daily life. You go underground to escape cosmic rays produced in the atmosphere, except for the ones you study deliberately when they pass through the earth. You surround the delicate parts with shielding to soften the faint echoes of radioactivity. You choose materials that are extraordinarily clean to prevent even a slow drift of contamination from raising the background. The result is not silence, but a new balance, in which backgrounds are predictable and the signal has room to appear like a small star in a clear night. On your screens, plots update with stately regularity. One shows the number of hits per sensor as a function of time. Another shows a sky map of reconstructed directions, gently updating as the night passes. There is no rush for interpretation. The maps grow like moss. Over hours and days and months, patterns emerge. More events arrive from certain neutrinos. The sun's neutrinos create a steady, soft glow in a specific region of parameter space. High-energy events, rare and striking, appear as slowly accumulating points in a gallery of special occurrences. You can imagine those pages filling in a large book, a book that will be studied later when daylight and fresh tea make longer thoughts possible. For now, it is enough to observe the gentle movement of the lines and the dots. Neutrinos can tell us about the interior of the Earth as well. Some travel through and from the atmosphere, and by comparing how many arrive from different angles and different energies, we can infer how matter along their path affects them. Subtly, they pass through the mantle and core as if through glass, but there are faint effects that show up statistically. Again, the emphasis for you tonight is not on the calculation, but on the image of particles passing through enormous distances of rock, as if passing through a dream of stone. They emerge mostly unchanged, like a thought that is held lightly and then let go. Imagine now the different personalities of neutrino detectors you have wandered through in your thoughts. Super Kamiokande, a noble pool of water in a giant cavern, glass eyes lining the walls like a galaxy drawn inward. Sudbury Neutrino Observatory, where heavy water made neutrinos speak in a new way, revealing that flavors transform. Borexino, a sphere of liquid that glows faintly when touched by a neutrino, with layers of shielding that cradle it in a nest of cleanliness. IceCube, with its long strings sunk into ice that is clear like carved quartz, listening to the sky from under the southern cold. Each one contributes to a gentle picture of a universe full of quiet processes. Each one invites you to sit and listen. Flavor transformation, or oscillation, can be pictured as a soft, continuous turn in a multidimensional space, a slow drift in identity. In your mind's eye, imagine a color that smoothly modulates from blue to green to red, not snapping, just blending back and forth with a period and a pattern. The neutrino does that as it moves. It carries 3 mass states underneath, like 3 strands woven together in a braid. The mixing angles tell you how the strands are woven. The mass differences tell you the rhythm of the blend. When neutrinos move through matter, the pattern shifts a little more, like a chord that sounds different in a different room. These are gentle images for a gentle science. It is good to know that even in such advanced experiments, simple practices remain vital. Cleanliness is a virtue. In certain detectors, people wear special suits and pass through air showers to remove dust, because dust can carry traces of radioactivity. Water must be purified to an extreme degree. Scintillators must be free from impurities that would glow in unwanted ways. Under ice, the holes drilled must be carefully made, the equipment lowered with steady hands, and the ice allowed to refreeze around the strings, holding them in place like fossils in amber. The technology is exacting, but the feeling is human. It is the feeling of people caring for tools, that care for ideas. The gentle rhythm continues. Your eyes drift from the main display to a secondary one that shows the data being written to long-term storage. Bars fill and reset with predictable cadence. Somewhere in the building, silent disk arrays wait, ready to accept the night's careful harvest. It is comforting to know that nothing is lost when you briefly look away. never tires. You are here to catch anything unusual, but mostly you are here because the presence of a person is a soothing inclusion, one more layer of care. We can think of background cosmic ray muons, those more common particles that can reach the detector even underground, as gentle intruders. They pass through with a strong signal compared to neutrinos. They represent a reminder that the universe is active, even through rock. The software learns their signatures and filters them out for specific analyses. Sometimes those muons are precious too. They calibrate the timing and help map the ice or water's clarity and scattering properties. They are like passing ships whose wake helps measure the width of a channel. Even the backgrounds are helpful companions when understood. Time moves slowly in the watchroom, not because it drags, but because it glides. The clock ticks with soft regularity. Your breath remains steady. On the desk, a small lamp casts a pool of golden light on the logbook, and in that pool, your pen is ready. Writing a line here and there anchors the night. At 0210, telescope network clear. At 0235, a large reconstructed track discovered by the high energy filter. Automated tag applied. You make a small note to review it tomorrow with the team in the daylight. There is no urgency. The system has it saved. The image can wait. Your eyelids are heavy, but comfortable. If you wish, you can close your eyes for a moment and just listen, letting the hum of the room form a soft blanket around your thoughts. On the other side of the world, in a long tunnel beneath flat plains, another experiment sends a beam of neutrinos to a distant detector. The beam is a controlled stream, and by comparing what was sent with what is received, scientists learn about mixing parameters in a methodical way. This is like sending a clear tone across a valley and listening to how the echo changes. The detectors along the way and at the end maintain their own quiet vigil, and their night watch, much like yours, involves a patient attention to stability and clarity. Each beam spill is recorded. Each spill is compared to expectation. Over months and years, the picture grows clearer. If your thoughts wander to the details of Cherenkov light, let them drift as if strolling through a garden. A charged particle moves through water faster than light can move in water. It is not breaking the universal speed limit because light travels slower in water than in vacuum. The particle sends out a cone of light with a characteristic angle, like a fisherman casting a net that expands as it moves. The sensors catch the light, and from the pattern, they reconstruct the particle's path. In ice, the light scatters more, so the algorithms account for that, mapping how the ice changes with depth, where dust layers exist, where clarity improves. Underwater or underground, the details are different, but the principle is the same. Particles draw traces in the dark, and those traces are red. There is a deep satisfaction in knowing that this work proceeds even when you sleep. That is a message worth repeating. The observatory, with its runs and routines, listens day and night. The waiting is serene, the listening is continuous, and the stories accumulate slowly and surely. You are part of that stream tonight, like You might imagine the faintest sound as a neutrino arrives. It would be the gentlest of taps, a light pinprick of illumination, almost imperceptible. That is the nature of the things we study here. They are not loud. They do not insist on attention. They are content to pass by unseen. It is through patience that their existence becomes known. It is through gentle and consistent observation that their properties become clear. Patience is the core of this place, being present, unhurried, composed. The architecture mirrors that patience. The walls are thick, the lights are low, the schedules are steady. People move slowly and speak softly. It is a refuge for quiet. It helps to picture the sun again, especially as the night proceeds. The sun that shines on the other side of the earth releases neutrinos that move straight through, while light must wait for the planet to turn. These solar neutrinos are like a constant whisper behind the scenes, a steady murmuring that is a signature of the universe's calm internal operations. Water Cherenkov detectors have seen them. Borexino has measured them with a fine brush, and we now know that the sun's core burns steadily. This knowledge is reassuring. No drama is required. The gentle rhythm continues with a cosmic clockwork that is measured in quiet quanta. You may feel a soft wave of drowsiness. Let it pass through you like a neutrino through rock, leaving only a small trace, a pleasant heaviness in your eyelids, a warmth in your abdomen, a loosening of your knotted muscles. If you wish, shift your posture slightly. Adjust the angle of your neck. Bring a blanket over your legs if one is nearby. Sensing comfort is part of the watch. Comfort allows careful observation. Tonight, your comfort is a goal in itself. The science waits gently while you drift, and it also accompanies you, unintrusive, like a friend who is happy to sit quietly nearby. The night reminds you of earlier nights when detectors captured neutrinos from a star that changed state far away, a subtle wave that arrived before light had escaped the dense interior. Those neutrinos were a prelude. They said, in a soft and factual way, that something had happened. Astronomers turned their telescopes later and learned more. In sharing those little particles, the universe gave a calm signal, a nod. This nod is part of what neutrino observatories can offer, an early, quiet awareness. The community built a system that listens for such nods and closes no eyes entirely, and yet still allows people like you to rest. The rituals of checking and calibrating are the foundation of that trust. Drift back to the instruments. Between the smooth black cabling and the carefully sealed connectors, the engineering is like a well-tuned instrument. The readout boards are trained to handle bursts without fuss. They buffer and shape signals, filter them and push them into storage. They are resilient to small fluctuations. When a sensor drifts, it is not a cause for stress. It is a small adjustment, a twist of a knob, a parameter change in software, something done with deliberate calm. The layout of the room aids this composure. Tools are arranged neatly. Notes are placed is smooth, a river of points almost indistinguishable from a single stroke. The gentle rhythm continues, and you feel your thoughts slow to match its pace. On a different day, the details of oscillation parameters would matter. Angles called theta 1-2, theta 1-3, and theta 2-3. Phases and normal or inverted ordering, terms that fit lightly on an alert mind. Tonight, they are more like the names of stars in a peaceful sky. You can acknowledge them and then let them fade into the background. What matters is the sense that through patient observation, people have measured something subtle and woven it into a coherent pattern. The pattern is beautiful in a quiet way, like a tapestry hung in a hushed hall. If you listen carefully, you may even imagine the water itself holding your attention. Water is a patient medium. It cleans itself through careful circulation and filtration. It allows light to travel far if kept pure. It is held in place by a vessel that was assembled with care, bolts tightened by hands that knew how not to over-tighten, seals checked and rechecked. It is monitored by gauges that read temperature and flow. The water fulfills its role as a calm field in which a rare traveller can write a luminous word. When the word appears, the photomultiplier tubes greet it with a tender touch, converting photons into a measurable signal. The conversion is small and swift, like the pluck of a harp string that is heard and then stills. Now, the night feels neatly bisected, like a page turned gently to its second half. You are halfway through this watch, and your body settles even more. If you could ask the universe one question, what would it be? Another plot shows the rate of atmospheric neutrinos, which appear as a slowly changing but steady presence in the data. If you could see the tracks, you would see them as faint lines passing through, sometimes long, sometimes short, gently pointing up from the horizon or down through the planet. Those events are little confirmations that the detector is attentive, that it is seeing what it should. In many facilities, the analysis of those events provides a daily bread of physics. Parameters are extracted over months and years. Comparisons with simulation anchor understanding. The population of neutrinos from the cosmic accelerators, those high-energy events, arrives more rarely, like occasional pearls added to a strand. The software recognizes their profiles, and when one appears, it gently tags it, and the record is made so that human eyes can admire it later. The night invites memory. You think of a time when you visited the detector. During the day, you walked on a metal catwalk that gave a soft reverberation under your steps. You saw the cables neatly bound, the surfaces meticulously clean. You saw the array of sensors, each one an identical guardian, and you felt a sense of calm repetition, like the rows of trees in an orchard. Omitting one sensor did not break the field. It was the whole that mattered. The uniformity was soothing. It is soothing now, too, to remember. A uniform array, a uniform procedure, a uniform pacing of time. The gentle rhythm continues. You might find it pleasant to link the concept of energy to temperature in your own body. Higher energy particles make brighter light. Lower energy particles make dimmer light. Sometimes the bright ones photons are like a breath, visible only when the room is very still. Tonight, the room is still. The detector is attuned to small breaths. It is content to sense them and then let them pass. There is no need to do anything in response. A neutrino event is a record, not a call to action. The world remains unchanged to human senses, except for the knowledge that another tiny truth has been captured. Researchers take turns on shifts like these, so that no one person carries the night for too long. Shift rotations and handovers are themselves gentle rituals. At the beginning, there is a soft transfer of information. At the end, a calm summary. You can imagine writing your own end of shift note now, even though the night is not over. You might write that nothing unusual occurred, that the detector behaved as expected, that data were collected without interruption. You might place a small sticker in the margin, a simple star or a tiny smile, a human gesture that declares this was a good night. Quiet nights are good nights in this work. Digress for a moment into the concept of direction. Reconstructing where a neutrino came from is like tracing the faintest scent on a breeze and turning to face its source. In water detectors, the ring of light on the sensors can reveal the direction of the particle that caused it. In ice, the time order of pulses along strings shows the path. The Earth itself becomes a filter. High-energy muons from cosmic rays cannot pass through, but neutrinos can. Seeing upward-going events is a signature that the thing you saw came through the planet. It is an understated marvel, but it can be taken in with a calm nod, like noticing that the tide has come in just as predicted. At some point during the night, you may gently stretch your legs. Rising from the chair, you feel the fabric slip quietly across your clothing. The floor under your feet is cool and steady. The hallway is softly lit. You pass a poster on the wall with a diagram of the detector, colored lines tracing arrows that show the paths of particles. Even those arrows look calm in the subdued light, like arrows drawn in sand during a peaceful walk on the beach. You fill a glass with water from the small kitchen area. The water tastes simple and clean. The glass is cool in your hand. You return to the desk, sit again, and feel the cushion welcome you back. The gentle rhythm continues. Neutrino astronomy is young and tender. Where photons tell us about light and electromagnetic processes, neutrinos slip out of dense environments with ease, carrying information photons cannot. That information is rich, but you can let it remain an unhurried possibility in your mind. The nighttime is not for complexity. It is for images that soothe and sustain. Picture a core of a star where light is trapped for a long time before it emerges, but neutrinos depart promptly, like soft messengers slipping out a side door. Picture the detectors as quiet catchers of those messengers, not chasing them, not pursuing them, simply waiting in place with open palms and calm expectation. The software that reconstructs events has its own rhythm. It tests many hypotheses for each event, considering whether the pattern of hits would be better explained by one path or another, one energy or another. It looks for the likelihood that matches best. This is like fitting a key into many locks, running gently to see which one yields. The code is not impatient. It tries options in a methodical way. The processors hum with that work, a low and steady thrum. The monitors show the results with serene certainty that this process can repeat all night and beyond. In some experiments, radioactive sources are deployed occasionally to test the detector's response. In such times, the event rate increases in a controlled and welcome way, like a gentle rehearsal for a performance. During your night watch, those sources are at rest. Their containers sit quiet in their racks. Fibers for calibration lie coiled neatly. The experiment feels like a sleeping city, with only essential services running. You are the night guard and the friend of the sleeping city. You appreciate its order and its resting beauty. Your mind drifts to the people involved in building these systems. Engineers design supports that are strong but not noisy, materials that are robust but not contaminating, sensors that are sensitive but reliable. Scientists wrote software that can catch and correct small deviations. Technicians assembled, aligned, and tested thousands of components by hand, each touch gentle and respectful. The detectors feel like gardens that have been planted and are now tended by watering and pruning on a careful schedule. This night is like a watering, a quiet walk among the rows, a checking that no unwanted growth has entered, that the fences are intact, that the soil is moist. The movement of time is a calm current, and you are floating with it. It carries you across minutes and hours without bumps or swirls. If thoughts of obligations arrive, you can let them rest on the bank for now. They are not needed here. Here, the only requirement is awareness that can slip into soft focus. If your eyes close for a moment, the system continues its hum. If they close for a few moments, the logs will still be there when you open them. If you drift, the night is broad and safe. Neutrino cross-sections, those measures of interaction probability, are tiny. That tininess is a reassurance in this context. The atmosphere and your own body are traversed by these particles without any impact you can feel. It is akin to a breeze that is so light it does not stir a leaf. The detectors themselves are built to amplify the rare cases where that breeze brushes a chime. The chime rings briefly and then stills. You do not strain to hear it. You keep the room quiet, and the chime makes itself known when it needs to. Remote monitoring allows the system to share its status with others. While you watch here, others may glance from their living rooms, peeking at a phone screen before brushing teeth, seeing that the night is calm. This too adds to the tranquility. The burden is distributed across time zones and people, so that any one person can relax. You are not alone, even when the building is silent. There is a web of quiet attention that runs around the globe, connecting soft lights in control rooms, home offices, and desks in university labs. The gentle rhythm continues. Occasionally, a gentle alarm might appear, not a sound, just a small line of text changing color. It might say that a single sensor has drifted in gain. It might say that a temperature is 2 degrees higher than desired. Your response is simple and smooth. You open a panel, adjust a setting, or make a note for daytime staff to address. There is no panic. The system is robust and the range is wide. You return to the main display and feel your breath settle again into its steady, slow tempo. The nature of waiting can itself be a soothing practice. In a world that often pushes for immediate results, a neutrino observatory asks for patience. It invites you to value small events and long accumulations. It tells you that subtlety is worthwhile. Through that lens, your own evening becomes part of a quiet tradition, a way of aligning your inner tempo with the gentle movements in the world. You listen, and in listening, you rest. Think of the gentle mathematics that might be unfolding elsewhere as data accumulate. Analysts will later fit models to the rates as a function of energy, adjusting parameters until simulated distributions match the measured ones. They will extract values and plot them over time. They will compare to predictions from theory and from previous experiments. Here in the night, you do not need those numbers. You can hold the idea of a curve that hugs a set of points, smooth and graceful, and that curve is like a path through a garden, guiding the eye past trees, benches, and a calm pond. You may have heard about the possibility of detecting neutrinos from the Earth's radioactive decay, the geoneutrinos that tell us about the planet's internal warmth. These have been measured by some detectors, adding a piece to the picture of the Earth's heat budget. This thought too can be gentle. It is the idea that even the Earth has a quiet inner life, a slow combustion that keeps it warm, and that the soft particles that reveal this can be sensed by a pool of liquid kept tidy and clear. Imagine the style of work during the day here. People speak in low voices, they point at screens, they nod, they type, they write on whiteboards with smooth markers, lines forming loops and arcs and simple formulas. Someone brings in a tray of fruit, pieces bright and fresh in the fluorescent lights. There are occasional meetings, scheduled in a rhythm that respects focused work. In the evening, the pace slows more. Night comes, and with it a deepening quiet. The building rests. The detector pauses between events like a living thing between slow heartbeats. The gentle rhythm continues. You watch a reconstructed event scroll into view on a visualization window. It is a track about 500 meters long in the ice representation, a thin line of blinking points that fade as the program plays the event, markers that represent pulses at each sensor. The direction arrow points slightly upward, suggesting an upward-going neutrino-induced muon. You look, appreciate the clarity, and let it go. Another event appears, spherical this time, short and bright, likely a cascade, each the size of a little dream, each saved, time-stamped, set aside for analysis like polished stones, placed into a bowl. The idea of a background that becomes a tool appears again. In water detectors, flashes of light from radioactive decay in the surrounding material can be used to understand the detector's timing and response. In ice, the distribution of noise pulses can help map the dark rate at each sensor and inform cleaning algorithms. Over time, these are not irritations, but features to be accounted for, like gentle ripples on a lake that do not prevent you from seeing ideas about neutrinos being their own antiparticles, about rare processes that would change our understanding of their nature. Detectors are being built to search for such subtle things by looking for special signals over long times. The waiting for those is relaxed. The desire to know is present, but it is not an agitation. It is a calm curiosity, like wondering what a distant path looks like without needing to walk it tonight. A small light on the console blinks to indicate that the clock has synchronized with the global time server. Time is one of the most important ingredients in this work. Precise time stamping allows events to be compared across detectors worldwide. If two sites see an uptick at nearly the same moment and their clocks agree, then a shared event may be indicated. The humblest feeling arises from this. Time is like a shared lullaby that many cradles listen to, and everyone knows which verse they are on. Knowing what time it is in this precise way feels like being gently held by a well-tuned system. A colleague in a different time zone might send a short message to check in, a brief greeting on a chat window. You reply with a few words and a simple emoji, a soft signal between two folks under the same sky. The chat then quiets again, respectful of the night watch tone. Messages and conversations can wait. The night is for stillness. The gentle rhythm continues. The more you relax, the more the concepts simplify on their own. The world of neutrinos is a world of rare touches, and to sense a rare touch, you create a large and quiet environment. Water or ice or liquid scintillator becomes a receptive space. Sensors become attentive eyes. Electronics become listening ears. Analysis becomes an unhurried reading. Teamwork becomes a gentle exchange of notes. The entire endeavor is like a careful embroidery, each stitch small, the overall pattern becoming clear only as you step back after many hours of work. You glance at the drift of time again. The hands have moved. The night is further along. Your body feels heavy in a pleasant way, a calming weight that signals safety. Your breathing is slow. The room warms slightly, or perhaps your awareness of your own warmth increases. The sense of watchfulness remains, paired with an increasing trust that the systems will call you gently if attention is needed. You are both present and allowed to rest. In the long arc of these experiments, discoveries appear like soft lights in a field at night. Solving the solar neutrino problem by realizing that flavors change, measuring mixing angles that quantify this change, seeing high-energy neutrinos from cosmic sources, those rare jewels in the data, setting limits on exotic ideas. Each light adds to a constellation, and together they map a sky of knowledge. The lights do not flash all at once. They appear slowly, in a pattern that rewards patient eyes. You can feel how this parallels your own evening. The day did not demand grand gestures from you. It asked for gentleness. You provided that by being here. If your attention drifts to the floor, you see it is clean and smooth. If your attention drifts to your hands, you feel their softness and warmth. If your attention drifts to your face, you feel the muscles soften, the jaw unclench, the tongue your ears. You hear the gentle hum, and perhaps a distant, unintrusive sound of air moving through vents. The gentle rhythm continues, and it welcomes you to do less, to do nothing at all. This watch has a quiet kind of purpose. It is not idling. It is not waiting in an empty way. It is like tending a candle in a calm room. The candle burns by itself, but someone is there to make sure the windows are closed to drafts, to ensure the wick remains neat, to touch the brass holder occasionally and feel that it is not overheated. The flame is steady. The flame is the detector. The room is this observatory. You are the caretaker who knows that presence is a form of action. On nights like this, your mind feels clear enough to taste simple truths. One truth is that the universe is continuous and gentle in its average behavior, and that even the rarest things happen without fanfare. Physics lives in that quiet, just as much as it does in bright breakthroughs and loud announcements. Another truth is that attention can be restful. By watching something unhurried, you become unhurried. By noticing stability, you become stable. By keeping a soft vigil, you are kept soft in return. You lean forward slightly and write another line in the log. At 0350, all subsystems nominal. Some high-energy candidates recorded by automated filters. You add a small heart in the margin for yourself, a private note that makes you smile. It is a good night. You minimize the window and let your gaze soften once more, this time picking out the faint reflection of your own outline in the dark screen. The reflection is friendly and familiar. Occasionally, you imagine a neutrino passing not through the detector, but through a person far away who is looking up at the stars. It enters, touches nothing, and leaves, invisible and harmless. It is a poetic image, a shared confidence. Ghost particle, as a phrase, becomes gentle in your mind. Ghosts here are not frightening. They are like dandelion seeds drifting past a window on a windless day, legal to ignore, soothing to observe if noticed. The gentle rhythm continues. Another calibration flash, subtle and exact. Another recording block closed and marked. Another small adjustment made to keep absolute time tight. Your movements remain unhurried. If you wish, you can shift your shoulders back and down. Let the muscles around your neck soften. Let the jaw loosen, and let your eyes rest. Allow your belly to rise a little on each inhalation and fall on each exhalation. If sleep arrives now, it will arrive naturally, like a neutrino appearing in the water with no push, no pull, no demand. Consider the idea of confidence intervals and uncertainties in a restful way. They measure how sure we are about what we know. The intervals shrink as we collect more data. That shrinkage is like snow slowly covering a field, smoothing the bumps, bringing a uniform blanket across variations. The process takes time and patience. In neutrino physics, the field becomes smooth across years of data. The scientist's confidence widens into a peaceful certainty that then allows new, subtle questions to be asked, gently. If visualizing as a calm rain filling a reservoir. Each drop is a recorded event. The reservoir is the archive. The level rises so slowly that you cannot see it in the moment, but over weeks and months you notice that more and more of the rocky shore is underwater, and the lake is larger. Standing at the edge, you feel a sense of steady growth, not from loud storms, but from constant, quiet precipitation. The detectors must sometimes be emptied, cleaned, and refilled, or cables replaced, or new sensors added. These operations are planned carefully and done with respect for the fragility of cleanliness. Even these days follow a calm rhythm, with checklists, rehearsals, and a pace that avoids rush. Night watches on those days feel different, but still gentle, as if sitting with a resting patient after a minor surgery, making sure they are comfortable. Tonight is not such a night. Tonight is uneventful in the best way. The gentle rhythm continues. Your thoughts might graze across the term supernova again. In the scientific context, it means a star changing in a dramatic way. Here, the drama is downplayed. You can choose to think of it as a slow exhale of a story that has gone on for a long time, and the neutrinos are the first part of that exhale to reach us. Detectors are ready to notice the increased rate, and networks are ready to share the note with telescopes. The process is careful, not hurried, and its purpose is to gather knowledge gently. In some lakes or seas, underwater detectors listen for acoustic signals as well as light, and arrays of sensors stretch out like nets beneath the surface. These arrays catch faint sounds or faint light. Water moves around them. Fish pass. Currents carry small bits of life past the sensors. The detectors continue their patient presence, unaffected by the lives that surround them, being good neighbors, anchored but respectful of the sea. The metaphor extends to your own presence in this room. You are anchored, not intrusive. You hold your place, and it holds you. Think now of the first detection of neutrinos, a story that involved a tank of water near a reactor and a method for catching rare signals by making a new element that could be chemically extracted and counted. It was a careful game, one that took years and produced a result that was definite and calm. Those early efforts paved the way for tanks that could see flashes of light directly, for arrays that could digitize signals in microseconds, for networks that could compare clock ticks across continents. The continuum from then to now is smooth when seen from here at night, a line that arcs gently across time. Your awareness might drift to the edges of your body again. Feel the back of your head resting against your pillow or chair. Feel the weight of your arms. Feel the contact between your legs and the surface beneath them. Each point of contact is an island of safety. The points connect into a whole map of support. It becomes easy to let go. The room continues its state of calm. The gentle rhythm continues. On the monitor, you see that the daily summary is approaching its next mark. The system will automatically archive files, generate visualization. Picture a small photon inside the detector. It is emitted by a charged particle. It travels in a straight line until it meets the glass of a sensor. The sensor's surface releases an electron. The electron is guided by electric fields and multiplied. The pulse travels along a cable. At the end of the cable, it is digitized into numbers. The numbers are passed to a computer. The computer writes them to disk. Later, software will find them and group them. It is a sequence of steps as simple in spirit as passing a note along a row of friends, each one a small relay of attention. The gentle rhythm continues. You are farther into the night. The air is slightly warmer from the presence of electronics and people, even if only one person is here. The building seems to breathe slowly. The ventilators bring in just enough new air to keep everything fresh. The smell of the cavern, clean and mineral, remains present but subtle. If you listen, you may hear a tiny sound, like a sigh, perhaps a chair settling or a pipe expanding slightly as the temperature changes. It is all part of the room's language of comfort. It is possible to spend a lifetime on these experiments, and it is also possible to be content with a single night like this. The experience is complete in small samples. You do not need the whole river to understand its flow. A handful of water on your palm tells you the story of the river's temperature and clarity. Similarly, a single shift tells you the story of this place's atmosphere and the care of its keepers. Your presence is enough. The detector's presence is enough. The night is enough. You allow yourself to think of morning in an unhurried way. Morning will come as a cool light in the corridor. A colleague will arrive with a quiet greeting, perhaps a soft smile, perhaps a fresh thermos. You will offer the logbook. You will say that the night was calm. The colleague's shoulders will soften. The world will feel ordered. But that is later. Now the night remains, open and slow, and you are in it like a boat on a still lake under stars. Take one more slow breath. Inhale gently, noticing the air's path. Exhale softly, letting the invisible pressure of the day move away. Imagine the neutrino sea again, a constant and harmless flood that passes through with no weight. This image is a permission to stop holding things. Let them pass. Let them pass through your mind without clinging. The detector will hold what is needed. The world hold what is needed. You can release the rest. The gentle rhythm continues, and if you wish, you can fall asleep now. The night watch will remain, and the ghost particles will move in their ceaseless, peaceful way. If you are still with me, know that you are safe, and that the room around you is a soft, sheltered place. The observatory's hum and the Earth's embrace are steady. Very soon, you may dream